find the distance between points P and Q. Now there's technically two ways of doing these, and I am going to do the hard way and then kind of mention in where the easy way would have come in if you'd done it that way. The reason I want to do it the hard way is because on this one, I can see it, how close they are to each other, so I can just count distances on my axes. However, it's not always that case. Sometimes these numbers are so large it won't fit on a coordinate plane that we can draw, so I want to go ahead and go about it the hard way. I want to go ahead and identify my 2 points. So Q is at point -2, 2. P is at point 2, 1, 2, 3, 4, 5. And to find the distance between those 2 points, well, I'm going to use my distance formula. D equals the square root of x 2 minus x1 squared plus y2 minus y1 squared. Now, whenever I look at these, I'm going to go ahead and label them x1, y1, and x2, y2. So x2 is 2 minus -2 squared plus y2 is 5 minus y1 is 2 squared. Now let's simplify this. 2 minus -2, minus negative is plus, so 2 plus 2 becomes 4 squared plus 5 minus 2 is 3 squared. Now, I mentioned that shortcut you could take earlier when you can draw it. I can always look at this thing as if it's a right triangle. And so I can count my distances of 4 and 3, and then do Pythagorean theorem, where this is A and this is B, and that's where I end up. Square root of A squared plus B squared, Pythagorean theorem. So there's your shortcut if you want to. Now I combine those together. 4 squared is 16, plus 3 squared is 9. So that is the square root of 25. And the square root of 25 is 5, leaving me with option A. Most common mistake here is not taking the square root and leaving it as 25.